You take 1 spoon of salt, you dissolve it in water, you see that it quickly dissolves. Now you take 1 spoon of chalk powder. You dissolve it in water, you see only a small amount may be dissolved, most of it does not dissolve in water. So we define a term known as solubility. Solubility is the extent to which a solute dissolves in a particular solvent to form a saturated solution. So we define solubility as the extent to which a solute dissolves in a particular solvent. When we have oil dissolved in water, oil does not dissolve in water at all. It forms a separate layer in water. So such substances which are completely not soluble in each other are known as insoluble. So oil and water, they are insoluble mixtures. So let's see how we can determine solubility. We have defined solubility as the extent to which a solute dissolves in a particular solvent to form a saturated solution. So solubility is the mass of solute by the mass of solvent. So this gives us the solubility of a particular solute in a particular solvent. And this is to make a saturated solution. So let's do a question. 12 grams of a saturated solution of potassium chloride at 20 degrees Celsius, when evaporated to dryness, leaves a solid residue of 3 grams. Calculate the solubility of potassium chloride. So we know that solubility is the mass of solute by the mass of solvent. When we talk of solubility, we talk of the extent to which a solute dissolves in a particular solvent. So solubility is mass of solute by the mass of solvent into 100. Now it's given that when the saturated solution, the liquid is evaporated to dryness. So we are just left with the solid residue. That is, now we have the amount of solute. So the amount of solute is 3 grams. And we started with 12 grams of solution. Now we want the mass of solvent. So mass of solvent is the amount of solution that we have minus the mass of solute that we have. So we get 3 by 9. So when we have 12 grams of a saturated solution and 3 grams of the solid residue is left in the end, so we get the solubility as 33.3%. Now let's see what are the different factors on which solubility depends. Say there is a class, it consists of some students. Now when their parents come to pick up their kids, the kids who are sitting on the sides, first their parents go and pick up those kids. Now the kids who are seated in between, their parents can come and pick up their kids. So it becomes a little lengthier process. So now the kids are distributed into different sections. So now we have distributed some kids in different sections. So now the parents can go to the particular classes and pick up the kids easily, as now there are lesser number of kids in each section. What happens now? We put one kid in separate sections. So we now distribute it even further. Now there is only one kid in each section. So it becomes a very easy process. Each parent goes to a particular class in which their kid is present and they can pick up their kid. So we see that as we are distributing it further and further, the process becomes quicker. So now what do you think? We have salt powder and we have lumps of salt. which one will dissolve faster? So let's see which one will dissolve faster. We start with a lump of salt as it is dissolved in water. The ions which are present on the sides, water molecules can come and take away the Na plus and Cl minus ions. But now we'll cut this lump of salt. So as we cut this lump of salt, we see that all the surfaces, most of the surfaces are now available for water molecules to act on. So the surface area available for the water molecules increases, and so we see that the solubility increases. So as the size of the solute particles decreases, the total surface area of the solute which is now exposed to the solvent increases. Since this surface area is increasing, more solvent particles can now act on these solute particles. And so the solubility of the solute increases. So as the size of the solute particle decreases, the solubility of the solute increases. So now which one do you think? Will salt powder dissolve faster or lumps of salt dissolve faster in a solution? So we see that the salt powder, greater surface area of the salt powder is exposed to the solvent molecules. So the salt particles or the salt powder dissolves faster as compared to lumps of salt. There are some presents for the kids. All the presents are kept in one corner of the room, and the kids are asked to take their presents. So now some kids go, they take the presents, they start opening the presents. After they are done, they leave. Then the kids who are behind them, they come, pick up their presents, open the presents, see, and then they leave. So as one set of kids, they open the presents, they leave. Only then the kids who are behind them, they can come pick up the presents. But now, instead of keeping all the presents at one corner of the room, the presents are now scattered in the entire room. So it becomes very easy for the kids. They easily pick up one present each and they open their presents. So, can you relate this with the stirring of a solute in a solvent? How does stirring affect the solubility of a solute? Let's see. So we add salt to water. Now if it is allowed to remain like this, the water molecules act on the salt particles and they act on the surfaces which are available to them. They cannot reach these salt particles. Now if it is stirred, what happens on stirring? All the salt particles, they start moving. So as they are moving, greater number of surfaces are now available for the water molecules to act on. Since now they can take away greater number of particles with them, so the solubility increases. So stirring brings more of the solvent particles in contact with the solute particles. So now greater number of surfaces are available for the solvent particles to act, and so stirring increases the solubility. So the effect of stirring is that it increases the solubility of the solute particles. What happens with temperature? How does temperature affect the solubility of a solute? We know that when the temperature increases, the kinetic energy of the particles increase. On increasing the temperature, the kinetic energy of the particles increases. This means that the speed of the particles increases. As the speed of the particles increases, the intermolecular space between the particles also increase. The intermolecular space between the solvent particles. On increasing the temperature of the solvent, the intermolecular space between the solvent particles increases. This means the space has now increased, so greater number of solute particles can now be dissolved in the solvent, so the solubility increases. on increasing the temperature of the solvent, there is greater space available for the solute to be dissolved, and so with the increase in temperature, the solubility of the solid particles increases. So the effect of temperature is that on increasing the temperature, the solubility of the solid particles increases. We define solubility curves. We can make solubility curves for different substances. These are the curves. They are plots which mark the changes of the solubility with the change in temperature. So let's see the solubility curves for a few substances. We see that for most of the solid substances, that as the temperature increases, the solubility increases. So say for example for calcium chloride, as we increase the temperature, the solubility increases. So this is true for most of the solid substances. This is because as we increase the temperature, there is greater intermolecular space in between the solvent particles. So greater number of solute particles can now be dissolved. But there is an exception in this case. Cerium sulfate shows lesser solubility with increase in temperature. Another exceptional case in this is sodium sulfate. For sodium sulfate, as we increase the temperature, initially the solubility increases and after that the solubility decreases. So cerium sulfate and sodium sulfate, they show an exceptional behavior, but for most of the solids, as the temperature increases, their solubility in a particular solvent increases. So the solubility of solids increases with the increase in temperature. Is it true or false? So we know that the solubility of the solids increases with the increase in temperature. This is because as we increase the temperature, the intermolecular spaces between the solvent particles increase, and so more number of solute particles can be dissolved. So with the increase in temperature, the solubility of the solid particles or the solute particles increases. Let's see how pressure and temperature affect the solubility of gases. We know that pressure has to remain in equilibrium. That is, the external pressure should always be equal to the internal pressure for any particular surface. So, what happens when you open a can of a cold drink? You see that as soon as you open a can, bubbles of a gas escape. You see fizz coming out. In a cold drink, that is in a can, the gas is in a compressed state. In the closed form, it is in a compressed state. That is, the internal pressure is more. So as soon as we open it, in order to equal or equalize the pressure, the gas present inside escapes. So the external pressure should always be equal to the internal pressure, and this is the reason why the gas escapes. Similarly, if now we increase the external pressure, so you'll see from this pressure gauge, as we increase the external pressure, in order to balance the external with the internal pressure, most of the gas particles, they enter the solution. So see what happens. As we increase the pressure, the gas particles are dissolved in the solution. And when we decrease the pressure, they escape. So in order to balance the pressure, that is the external pressure with the internal pressure, if we increase the external pressure, the gas particles enter the solution. Now the pressure inside is more, so if we decrease the pressure, the gas from inside the solution escapes. So pressure should always be equal. And such a concept relating to this was given by Henry as his law. Henry's law states that the pressure above the surface of liquid is proportional to the solubility of the gas. The solubility is defined as the mass of gas dissolved in a fixed volume of a solvent. So as the pressure above the surface of liquid increases, as we increase the pressure, more of the gas particles now dissolve in the liquid, and so the solubility of the gas particles increases, and vice versa. What happens when we increase the temperature of the solvent? We know on heating, the kinetic energy of the particles increases. Now when we heat the solvent, it has both the gas particles and the liquid particles. So the kinetic energy of both the gaseous and the liquid particles increases. But the kinetic energy of the gas particles increases to the larger extent, and so they can easily escape. So on increasing the temperature, as the kinetic energy of the particles increases, the kinetic energy of the gas particles increases tremendously, and so they can easily escape and gases evaporate. So on increasing the temperature, the solubility of the gases decreases. As we increase the temperature, the gases readily evaporate. This decreases the solubility of gases in the solvent. So with the increase in temperature, the solubility of the gas particles in a solvent decreases, and it is opposite for the solid particles. In solids, we know that as we increase the temperature of the solvent, there is greater space for the solute or the solid particles to be dissolved. So for solid particles, the solubility increases with the increase in temperature, but for gases, it is the opposite. With the increase in temperature, the solubility of gases decreases.